Hello everyone, I hope you're all keeping well. For today class, I have this pre-recorded lecture, and the reason is because I have to attend another meeting. So I explain what I have for today, and there is a small work at the end of lecture which you're going to use your softwares very similar to what we do in lab, but it is very small, and this will help prepare you for the project that I will introduce on Friday. So this is week 10. We are starting chapter 10 from the book, and we are going to look at counters. And I will limit it to only looking at two main counters of counting down and counting up. So the counters are very good elements. They are built in the PLCs, and they let us check how many times a signal is going up and down. And that way we can measure. For example, if for those of you that had the chance to go and look at the lab, you saw that we had conveyor belt, and then we could put boxes on the conveyor belt, and using the sensors we could actually count how many boxes are passed from that conveyor belt. Hopefully next semester, when things go back to normal, we are going to see that in actual physical scene. But for now, we are just imagining that we are dealing with a project that need to count some fact. For example, if we are looking at a tab, how many times it opens and closes. So if we are looking at, for example, a parking spot, how many times people come and pass by, or a door, how many times it opens and closes, and anything that needs to be counted, and that gives us important information. One project from years back was to count how many people enter the building. And nowadays, because of this COVID-19 restrictions, you can imagine how useful is that. So we're going to look at the counters, and on Friday you're going to see how useful it is and how we can actually make use of that for operating a washing machine. Many of our house appliances are using that, and we're going to look at them. So basic types of counters are the count down or count up. And the count down, the short name in especially in Rockwell, based on Alan Bradley software, is called CTD, and the count up is called CTU. And today I'm looking at CTU, and hopefully for next class, or maybe if it takes longer than one class, maybe next week, we are going to look at the CTD. And that will complete the chapter 10. We have these two types, and reset becomes very important for using the counters. And you are going to see how we can use the done pin, very similar way as we were using for timers, to turn on or turn off any output. Now I'm going to look at. This is how it looks like. So if you open your software and you go to the menu timer counter, so far we were using only TON and TOF. Now it is time to look at the counter, and it is called CTU. So it is for counting up. So this output instruction counts up for each false to true transition. You know what that means, false to true, right? So it is looking for edges that we are transiting from 0 to 1, from low to high. Any transition from that type, our counter can measure it. So the conditions preceding it in the wrong and produces an output when the accumulated value reaches the preset value. So we have a preset value. We are going to have we are going to say, okay, count from 0 or whatever up to that value, and then we are going to have over value or overload. So overflow or overload. So that is how counters work, and the wrong transitions might be triggered by a limit switch or by part of traveling past a detector. So somewhere before this line we might have something happening, and as a result of that this contact here might be activated. And once this one is activated, the counter is starting to count. Now, how we can use the CTU. This part is actually not taken from book. It is taken from the help of RSLogic software. So it says the ability of the counter to detect false to true transition depends on the speed or frequency of incoming signal. That is very important because if that frequency is not well managed due to the delay and the time that the scanning is going on, so we might get trouble. So we might consider that how fast or how quick that transition from false to true, from 0 to 1 is happening. If it is too quick, our counter might not have very accurate result. So the on and off duration of an incoming signal must not be faster than the scan time. This is exactly what I explained. Each count is retained when the wrong condition again becomes false, permitting counting to continue beyond the preset value. This way you can base an output on the preset but continue counting to keep track of inventory or parts moving on conveyor belt or something like that. The counterflows use 3 words per element. So we have counting up overflow bit, which is called OV, and we have the done bit, and then we have the count up enable bit. So these are the most important things that we need to deal and take care of with when we are using it. So CU bits, the enable pin, is always set prior to entering the rem run or rem test mode. You know what is that, right? The run mode and the test mode. So we should put everything properly before we go run. We already know that. Now this part is taken from the book, and this is one example which I'm going to ask you to do it on RSLogic, and this will prepare all of us to look at counters in bigger picture. So we have the CTU block here, and you can see that we have one input. You can name it whatever you want, and then this input is connected to the enable pin of the CTU, and then it is connected to the input of the CTU, and then the enable pin is here, CU1 here, and then we have the done pin here. So the done pin is being used the address for activating another contact here, and then that contact is connected to another output. And then we have another input for the reset, and you can see that the reset is connected to our counter. So looking at the time plot, we can see how exactly the counter is accumulating. So by running this example, we will see that how the counter works, and we are going to turn on and turn off the input to test the counter. How we do it, we just simply, in simulation scenario, we just right click and we do the force on and force off, force on and force off. So we continuously do that, not too quick, in a good time fashion that goes well with the scanning time and everything. And then we are going to look how that accumulation happens and how we have these pulses coming. Obviously we don't see them from the LAD point of view, but you will see when they are activated, and then you are able to plot that. I'm not going to ask you to plot it. I'm just going to ask you to make this LAD diagram in RSLogic and see how it works exactly. You don't get any error, and a counter is actually counting and it is accumulating. So the accumulation starts from 0, for example, and then goes 1, 2, 3, 4, and then goes to 10, and it even goes higher than 10. because we can have some, overflow value. So that is for today. And for reading from the book, these are the facts that are associated with this counter. So the book says preset value is the count value that the counter must accumulate before the counter output is 1. So the counter done pin, you can see the done pin is turning to 1 only when accumulation is completed. And in this case, we have 10 preset values. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is the 10th edge, and that's why the accumulation is complete. And then we have 1 in the output, the done pin. The accumulated value, ACC, is the accumulated number of 0 to 1 transitions of the counter row. The count up CU enable bit is 1 when the input logic makes the up counter rung 1 and 0 when the rung is 0. So the CU is the enable pin. And you can see that it is working very similar way as the input is working. So it is going to be very similar to the input. Whenever the input is raised up, the CU is also raised up. Whenever the input is 0, the CU is also 0. If you connect that to a contact and then, for example, in real applications, if you connect it to LED, you will see that lighting up, flashing, going up and off, on and off. Now the done pin is 1 for both counter. It means that for counting up and counting down, when the accumulated value is equal to or greater than the pre-value. The preset value in this case is 10, and when and 0 when it is less. So the done pin is 0 all the time before the accumulation reaches the highest value, the preset value. And once reaches the highest value, becomes 1. The count up overflow bit is 1 when the up counter increments above the maximum positive value. So as I said, we have this overflow bit, and you can see it by double clicking on the counter, which is on the left side. I will show it in the next slide. The reset returns the counter accumulator values to 0. Reset is going to reset everything. As long as reset is 1, accumulate ACC and all output bits are held at 0. When reset is 0, the counter is able to start counting. So on the left side, under the timers, you see counters, and it is C5. So if you double click, this window opens up, and then you can see the bits that we are talking about. So we have the preset value, ACC, we have CU, CD, done pin, overflow value, UN, and UA. For those that I didn't mention, explore it yourself and look at the help and see what do they do. Now I want everyone to, well, my plan was to discuss it in breakout rooms, but because this event came up and I have to attend it, so I'm pre-recording myself. I want everyone to make this counter work and upload your recording and your code on Brightspace. So good luck, everyone. I hope you enjoyed. So you're going to have a very simple program. It's not going to take long. It's just a matter of how you put the values for CTU. And it is very interesting, and you're going to use it for Friday project. Well done. Okay.